Okay, it's time. So again, hello and welcome to another session of our Monitoring Matters webinar series. We hope you enjoy the next 45 minutes with us as we will show you how to monitor UPS, PDUs, and environmental systems with Paessler PRTG. And before we start, I will go through some housekeeping details. Right now you are all muted and your cameras are switched off. But you can still participate because you can use a feature in Zoom, the Q&A feature in the menu at the bottom of your screen. And you can also use the emoji feature as well to react. We will do our best to address all your questions as we go along. But if we don't have enough time, don't worry, because we will send you the answers to all of these questions in an email later this week or the beginning of the next one. The session right now, as you can see, is being recorded, and you will receive this recording along with the presentation via email later this week. And your participation is very important. So we will also have a poll or two that we'd love for you to help us by participating during the session. I am Jimena, and I'll be your host for today. And right now I'm going to hand over to our experts, Henk and Steven. The stage is yours.
Thank you. My name is Henk. I live in the Netherlands. I'm was roughly 7 years with the Paessler company. I participate in trainings as a trainer, but I also develop the training material, and I also help in the implementation side on the customers to show how you best can implement our product.
And my name is Stephen. I'm one of the pre-sales consultants here at Paessler, based in the UK, and I've been with the company just over 6 years. And I'm here to help all of our new and existing customers understand what PRTG can do for them. So our goal for today then, so what we want to achieve from this session is that we wish to allow you to expand your monitoring by understanding what you can do with PRTG in the space of those UPSs, PDUs, and environmental systems. And we want to inspire you to perhaps use some of those sensor types that you have not yet used in PRTG to achieve that. So quick run through of the agenda for today. So we're going to look at some common situations in the monitoring space for these types of devices. We're then going to have a quick deep dive of UPSs and PDUs before having a further look at the OPC UA protocol, which is used in the OT environment space. And then we're going to have a further deep dive into environmental systems, and we'll end up with a Q&A session. So looking at the common situations, first of all, we will have today many new and existing users of PRTG. And when you install PRTG, you may install PRTG for a variety of reasons. It may be that you've installed PRTG and so far you have purely implemented it to monitor uptime only. So you may have deployed many ping sensors and you may have a dashboard that's showing what is up and what is down. Likewise, it might be that you've deployed PRTG and you have a mixed estate of both IT and OT. So PRTG is an all-inclusive monitoring solution. We can monitor the IT space, the OT space, the IoT space, and the IIoT space. And it may be that you have deployed PRTG to monitor everything within those environments all in one application. And it might be that you've deployed PRTG and you have ran auto discovery and added all of the devices and applications that were found initially and added some initial sensors to those devices. But beyond that, you haven't done any further work on configuring your PRTG beyond what is available out of the box. So using PRTG on a daily basis then, so you've already got it configured, you're gathering data, you may have added some basic sensor types, so monitoring ping, monitoring uptime, you may have added sensors for CPU, memory, traffic, and those sort of metrics. But there's much more to PRTG than that, and that's the purpose of this series. We're going to go through what some of the possibilities are, and of course, in today's session, that focus will be on those PDUs, UPSs, and environmental systems. So as mentioned, the focus for today is on the power distribution units and the uninterruptible power supplies, as well as the environmental systems that you might find in your IT and OT space. And we're going to look at the type of protocols that we use to monitor those devices. So notably SNMP, Modbus, and OPC UA, among others. So first question, of course, is what do we have in our environment? Do we have PDUs or UPSs or perhaps both? So let's look at the key distinction of each. So the UPS, the uninterruptible power supply, of course, the key features of that is that it has battery backup capability. It offers the power conditioning by cleaning the dirty power from the wall. It offers surge protection and, of course, automatic switchover during outages. The PDUs, on the other hand, power distribution units, these are for offering multiple outlets for your IT equipment. They even the power distribution across your rack or estate. They have remote monitoring capabilities on the advanced models and professional grade power management. Typically, PDUs and UPSs work together. So a common setup is that you will have power that comes through the wall and feeds the UPS, which provides that backup and protection. The power from the UPS will then be sent to the PDUs, which will then distribute that power to multiple devices within your environment. So taking a quick look now at the top manufacturers for UPSs. So we have Schneider Electric, based in France, Eaton Corporation in Ireland, Vertiv Group in the USA, Huawei Technologies in China, and Rittal in Italy. And I'm sure that you'll notice some of those vendors already. Other top manufacturers include ABB, Delta Electronics, Emerson Electric, Toshiba Corporation, and K-Star. And just to conclude with the list here are some other notable manufacturers in the UPS space. So among these manufacturers, I'm sure we've covered off one or more manufacturers that you may be using within your own environment. Likewise, for PDUs, you will see that there's much crossover here. So the top 5 market leaders in the PDU space are Schneider Electric, again in France, Eaton Corporation in Ireland, Vertiv Group in USA, Legrand in France, and ABB in Switzerland. Other major players include Delta Electronics, Emerson Electric, Siemens AG, Hewlett-Packard, and Cyber Power Systems. And again, some other notable mentions in the list there. So before we look at environmental systems, let's first take a look at some of the protocols that we're going to use to monitor those environmental systems. So the first protocol, of course, is OPC UA, which is widely used in the OT space to monitor a number of different devices, which you can see there. So common devices that you might already be familiar with, of course, are programmable logic controllers, your PLCs, your SCADA system, so supervisory control and data acquisition system, your HVAC system, heating, ventilation, and air conditioning, and CNC systems, computer numerical control systems, among others. Another common protocol in the OT space, of course, is TCP Modbus, which, of course, we have sensors for in PRTG as well. And this protocol is used to monitor many industrial devices. So again, there's lots of crossover here. We're monitoring the PLCs, the HMIs, so the human machine interfaces, and the RTUs, the remote terminal units. And we do this to measure a number of measurement and control instruments, such as temperature, energy, among others. And again, some of the devices that use TCP and Modbus here, you can see on the list. So we've got the power systems, the building automation, and the motor and drive equipment that you might find within an industrial setting. Now, within an OT space, of course, within an industrial environment, you will find that you have many physical sensors. And these physical sensors will monitor all kinds of different metrics. So these may be things such as temperature, humidity, air quality, radiation, gas, water level, soil quality. We have physical monitors for all of these, and these will connect back to a system that we can monitor via one of the protocols supported in PRTG. So now we will move to a poll.
Yes. Thank you, Stephen. Before we continue, it's time for a poll, and we want to know which UPS vendors you currently use. You're going to see the poll starting right now on your screen. Please select all the options that you need. You have Schneider Electric, Eaton Corporation, Vertiv Group, Huawei Technologies, Riello, or others. We'll give you 10 more seconds and then I'll stop. Okay. And you can see the results. We have in the first place Schneider Electric, then followed by Eaton Corporation, others, and Vertiv Group. Back to you.
Just going to say hello. So I will take over from Stephen here by going a little bit more into PRTG details. As we saw, APC is also in the US and a very well-known brand. It used to be the brand name, but it's these days Schneider's Electric. So that is something, but I think APC is known by everybody. What you see is that APC has its own settings file and OID lib that you can find in PRTG already, and you can use that to make a sensor, and we have done that for you already. It's based on a MIP file, and this screenshot typically indicates a MIP importer that you can download for free, and with that you can indicate which additional information you do want to get into a sensor. All those IDs, these numeric strings, they represent a value, and the text in front, it gives you a hint, and they're not always that clear, but they give you a hint what it will show you, what it will tell you, the temperature and the voltage and so on, all kind of things. Be aware that they may need some calculations. For instance, if a device says I'm 365, then you may think it's very warm, but probably you have to divide that value by 10. Those kind of things. But that's a little bit of experience and also on knowledge-based articles that we have. By the way, this kind of things we train you on and in our trainings. So if you feel like, hey, I could use some assistance, then find how we can help you with that. I will show you a few slides and then go into the examples of the sensors that we use. So here we go. What can be monitored? That's important. And UPS is, of course, a big device that has all kinds of smaller components. They may produce heat. They may need cleaning, all kinds of things that can happen. So there is a health sensor. Based on this PowerNet MIP, as you just saw earlier, we give that an overview of the capacity, how long it will last until the battery is down when the original power is cut off for one or the other reasons, those kind of things, because at some point in time, you don't want to stop your physical or virtual server abruptly because it could break hardware. Even if it's a virtual machine, we need hardware, of course, and those kind of things. Also, the power, it should be kind of flat and not too spiky. If that happens, then the device also suffers issues. That's not good. So those kind of things are really important. And the channels, of course, for people who haven't played so much with the product yet, a value is measured against a threshold, and that threshold defines in what state we put a sensor. As you can see, normal, that is what we want. That would have the color green. And if it gets in a direction that we say this is not desirable, but not too far off from normal, we put it in warning. Very logical, of course. and that is continuing with alerts and even unknown. Sometimes a sensor does not get, PRTG does not get information from a probe, and then we have to wait until that happens, and until then we say, we don't know. Scanning intervals are also important. You don't want to pull things too often. So therefore, the default of the product is 1 minute, as you can read. For certain things that is even too fast, we can slow that down to less because that expands the capacity of your PRTG server. So here is the what can be monitored. So the complete UPS health status. And I think this is, I already had that one, apparently double. Here is one of Eaton. Also here we have a battery status and similar kind of functionality, of course, that the sensor offers. Why not? And it has that same thing. If I go to the site where we have the sensors. So here you see my first tab. I have prepared a few for you. Here you see a group called UPS, and then to the full extent, uninterruptible power supplies, and you see 2 nodes in there representing a lot of sensors, in total about 50. That's how we do that. You can make such a group in your device tree yourself. The product is quite open. You can set up quite a lot without being forced in a fixed structure. So that's a very positive thing about that. So I take the next, and there you see the APC 1500 device being listed in 22 sensors. And of course, this one, the APC UPS health, is giving you that overview of the state that the UPS is in. For the people who are new, green, of course, like a traffic light, it means it's okay. And here you see different colors indicating that something is needing attention or even very much attention because it is in a down state. So you see the voltage, you see the lifetime, you see the time remaining is over here. So in 1.36 minutes, then the system has no power left to support all the devices that use the energy that is in the battery. So then at some point in time, with scripts, you can make that adequate actions are taken. So if the power is not restored, you can make that there is a graceful shutdown of the devices using the power. That is how you would use PRTG. If something goes, if the needle goes into this direction, you would first see that banner go yellow and then of course go red. But in the background, by notifications, triggers, then you get either emails, SMS, or both tickets in your ticketing system. That is how you use the product for just the people who haven't used that before. Switching to the Eaton, similar amount of sensors. And also here, a output and also the health sensor. I have that on here. And over here, I took the output or the input at this moment to show you that in this case, we have a SNMP protocol activated to get that information. And this information is shown by the MIP file by the device in a table. You see the very little channels over here. How do we get that? As mentioned earlier, you need that OID, that object ID from SNMP to know where that information resides inside that device. And once you have that, you get that and you indicate it. You give it a name. And if there are more objects, for instance, if there are 2 fans turning, then you have to tell whether you want the first one, number 0, or you want to have the second one, number 1. So those kind of things you need to do. And then also you need to tell what kind of units it is. In this case, we speak about voltage. So that's how you set up those sensors. As it is a table, it can contain multiple settings. And in this case, when creating it, you have more or less finalized the sensor, but you have the ability, as you can see, to go until 10 values, and that is not done in this case. The UPS health from this device, from the Eaton, is based on a SNMP Custom Advanced. So you see that the concept is the same. We still use that OID, but we get more channels in this case. If I go to settings again, it looks quite similar. And here in that case, you also see that we have a lookup assigned. That lookup file is more or less a translation between a value that PRTG doesn't understand. If I would say to PRTG, I'm in a state 6, then he would shrug his shoulders. If it would be a human, say, I don't understand. But you can make a translation, say, okay, 6 is in this case not good, whereas 6 could be very good in another case. So that is what you do with lookup files. So if you go back, you see lookup files like these, and all the colors, and they, like here, they have their own ID, but also their own meaning. So if I go booster and one more, it is like, there we go, reducer. So you see for the same color, 3 different slices, 3 different statuses. That's how PRTG works. So from the UPS, we go to the PDUs, but before I continue with the slides to give you a few ideas how they might look like. So in here, you have 1 slot to put the power into and a few more, in this case 8, to get the power out. So that is what you call distribution. And a device like this can be, for instance, in the top or in the bottom or in the back of a cabinet in your data center. And if you need more of that, sometimes you have the 2 of them, one on the left, one on the right, as we will see later. But yes, they have functionality as well. So first of all, they need to not blow up when all of a sudden a spike would come. I mean, not every organization has a UPS, so some people only use PDUs, which is fine. But of course, it's better to have both. Power is then dealt with, and when the temperature is rising, we need to monitor that as well. So if the device gets too warm, it moves in physical shape, and that could break, so that's not good. Of course, fire suppression and detection is more or less in more expensive type of devices, but it does exist, and you can be aware that yeah, things get overheated, and then you prevent a fire with that. Also, if a other problem is, like for somebody unexpected takes out the power, that could be seen as an exit and that you could trigger on. Again, that is the functionality of the device, but to get to that information, you need to have access via certain protocols to see that. For instance, you can configure such a device using HTTPS. And yes, you can also use internally HTTP, but HTTPS is of course more secure. But these protocols, as we see here, can be used to set up such a device and also monitor the device, because SNMP is typically more used for monitoring than setting it up. HTTPS is very often more on how to configure things. What you need depends on how you use the devices, but for instance, the FTP and the SCP could be used for file transfer. For instance, firmware should then be dealt with. This device looks quite different. They put a left side and a right side PDU next to each other to make that easy on a picture, but you see they are connected via the cable. They have this management module. So in other words, there are a lot of things they can do. And again, many features to make life easy. Remote power recycling. So if there is an issue, you could restart that device by itself, and all kinds of different things. Like PRTG, this device has a RESTful API. Is that a requirement for you when you want to buy those kind of things? Well, that is something different, but you could use that API for instance, a REST sensor. We have REST sensors that you could use there for as well. If you want to know more about them, then you follow the links that we provide under the slides. And the different Eaton one, you can see here, SNMP, REST, MQTT, and so on. So it really depends on the model of the device, what kind of features are offered by the vendor. Again, most of them are not activated by default. So in the setup phase, you have to do that. And that when you know what has been set up, you can use one of those protocols. Sometimes people forget that the device needs to be activated by itself. So over here, I have a Rittal, one of the other vendors that we didn't list yet, but that is also a well-known one in Europe. Don't know how well-known it is in the US, but we have that here. Again, HTTP or HTTPS, that is depending on how you work internally. And it gives you functionality that it alarms you when the temperature is getting too high, the air is too moist, too humid. Access that people can plug or unplug, smoke and so on, that is all needed. You want to keep your data center up and running to the max. And these devices, mostly nicely locked into a cabinet, that will be secured already by the cabinet, but still they need watching because all of those features. Here are the protocols. Again, not always everything is enabled by default. We will see that on the next slide, that certain things offer that in default in setting it up, but yes, you can do that. A Gude, also a well-known European vendor. You see here a screenshot from the interface when configuring the PDU. You see that you can use the protocol MQTT, message queuing transport, but you have to switch it from no to yes and then set up that information. Over here, you see a user and password. Again, that is something that you have to know, otherwise you do not get contact. I mean, even was SNMP version 1, one of the older monitoring protocols, you have to indicate that you know how you get access. With protocols like these, you have to set those credentials on the device level, not on the sensor level. So for people who have already played with that, they may have found that a little bit weird, but we have a lot of settings on the device level for those kind of protocols. SNMP, Simple Network Monitoring Protocol. Old when it comes to version 1, modern when it comes to version 3. Not all devices have the capability of speaking the 3 versions, but some do. And very often your company has policies in place that allow you to have version 2, sometimes not even, and then they only allow version 3. That is one important thing that you have to think of when setting up protocols like SNMP, that you have to have the right version. First of all, for your security in your company, that you don't get your recommendations. So that is something, but for the rest, then you need to be there. Good. Why? CPU utilization, memory, temperature, all those kind of essential metrics you can get out of SNMP, and very often the MIP files are publicly available, and very often if they're not publicly, you can get them from the vendor. A more modern protocol is OPC UA. OPC by itself has a few versions, and Paessler only focuses on UA, so that's why we don't see the other OPC versions. And again, the OPC versions are not interchangeable. So if you have an older kind of device, then you may have to activate one of the other protocols that are offered by that device. We have 3 sensors. An OPC UA server is not per se a Paessler component. It could also run on a any other device. There are also cloud-based OPC UA servers. SCADA servers also have a lot of OPC UA information. But basically, that sensor gives you the overview of how your server is doing. Are we dropping information or not? For your security, we use, of course, certificates. And when an expiration is due, you would like to be in time and replace that. That's also why we have that sensor. But actually, the real information is picked up via the OPC UA custom sensor. And this is where you get the information from by specifying node IDs. That is very small compared to OIDs in SNMP, but that's how we do that. By the way, I forgot to tell, when you come to OPC UA, Paessler has an extension which then can run a Paessler OPC UA server, and that can easily integrate into your OT environment, specifically into SCADA systems, to make your staff earlier and maybe better informed about issues that are coming or already exist than without that. Environmental systems. You have had already a large overview from Stephen, but yeah, that doesn't need to be repeated. But the purpose is, of course, that we find all kinds of information, and not necessarily in a data center or whatever. So there are different things. You probably have seen OT devices that run on battery using LoRa protocol to transfer the data that such a physical sensor sends over to the data center and runs very slow frequent, not so much as every so many seconds or so many minutes like PRTG sensors do, because they run on a battery and the battery needs to last 5 to 10 years or something. But they can be monitored as well. No worries about that. REST, HTTPS, MQTT, SNMP are also used, but not so much for that modern type of devices. But yes, they do exist. Underneath, you find the link to a device like that. It's a multi-sensor, and what you see here is that it only needs a network cable with power, so the PEO, and PEO switch, and then you can all have these values brought to your attention. So that is a small little device that gives you very much about the environment that it is in. This is not made for like big events or something, then you have to have bigger ones, but for smaller rooms in buildings, this is a very good device to have that kind of information. Another one, a Gude, here as well. You see the network cable, and then you can put in other sensors, physical sensors from that company, and maybe they even work with other ones. That's not my expertise. But it is a kind of communication box that allows that kind of information to be transferred automatically to you. And you can see it is done by an antenna to pick up information, but also it can work with an internet cable, an Ethernet cable, so you can get that information back. So let me switch back again to show you how that looks like in PRTG for a few things. So here we have again a power distribution unit, as it officially is called, group. And in there you see a few vendors with a few devices. And yeah, that gives you the same overview. You see it's more populated than we had previously, but that is not so much important. You can make, again, this structure to your likings. You can also put little groups like this on physical locations within your device tree if that helps you better. I have here a Modbus TCP custom sensor. As you can see, it is on a Rittal PDU, and this path is the path to this sensor, and it gives you the socket overview. If I go to settings, you see that there is a port on that device and a unit ID. Those are the major important things to know how you should talk to that device. Then, to interpret the data correct, you have to have an idea about how is the data formatted. It is just bits and bytes. So by setting this in the right way, and that's all in the documentation of your vendor, then you get that data right. Several registers are often offered. Compare them to the OID from SNMP, and then you know what of kind of information is coming there, and that you can then bring into your sensor. And as you can see, people have already said that. Once set, certain things cannot be changed. So if you feel like I want a different register number because you probably would like a different value as a matrix, that's possible as long as this type of value, data type, and register type remain the same. Then you can change it. Otherwise, delete the sensor and create a new one if this was not what you wanted. From a APC PDU, we see that there are also, again, a few sensors over here. And I have just given you the overview. Over here, in that same device, oh no, this is not the same. No, oh no, this is not the same device. This is the Eaton device, sorry. Here I show you a sensor that gives you a total of used power. And over here we see that we have a sensor factory sensor. The last word is sensor. What does that do? It has a sensor or more sensors that it gets information from the channels. So for instance, in this case, let me give you the formula, which is under settings. What we do over here is that we look at a sensor with ID 4950 and a sensor called 7588. And we take that information. We take the information from channel 2, 3, and 4, and then we do from both sides. And we add that all up into one value. And in this case, we gave that a label like active power total. And then we said, this is, yeah, these are watts that we are counting up together. You can do multiple calculations in this sensor. So what I did next is that I give you one of the originals. So over here you see this 4950, and you see here are the channels 2, 3, and 4. So they added up these from this sensor and from the other, and that gives them, if I go one more back, a value where they total come to nearly 1000 kilowatt, 1000 watts. Okay, so that is indeed interesting. The Eaton device, again, power consumption. They have used a SNMP custom, and we have already shown you that. It's just a listing of OIDs. So the MIP file helps you to give that kind of data, and therefore, yeah, you can do that. If you need the right one, use such a tool as I showed you earlier to find what the kind of text there is in that file to help you. A Rittal PDU, you may wonder why all these gauges are big. Well, people have here raised the priority, so they blew up. So if you feel like, hey, maybe the voltage is more important than the power, then you might want to reduce the size by lowering the priority. Those kind of things, but I guess everybody who has used PRTG is familiar with that. Also here, everything is just quite simple. That is the good thing about this device. It comes up with everything that you access automatically. Again, a Modbus sensor, TCP. We also have RTU kind of sensors, so that is no problem, but we don't use them here in this this demo because we speak about UPS and PDUs, so that kind of things. And again, the same things before, the port numbers and the data types. This kind of repetition. So given the time, I will quickly go over a few more. So here is the central management console from Rittal, a device which typically is a gathering device. It gets information from other devices, from other sensors, and then brings that message in a central place. Like here, you get all that information from all the connected devices. So over here, for instance, in door status, you don't want cabinets to be open or even data center doors open, so everybody can run in and out like it is a shop. No, you want that for all kinds of reasons being shut to only legalized staff, so you don't want that. But also the cabinets should be closed because people should not play with cables and switch on and off things that they should have. So that is something that is done on that part. Oh, that's the device, sorry. I should take the next one. One of the things that we have on the Gude is that we have enabled the MQTT protocol. And in this case, we use the round trip sensor. We have, again, 3 sensors for MQTT. One is for to subscribe to a specific topic. The other one is for the server itself. And the other one is this one to see how quick you can send messages and get messages back. If that gets slower, then you have to do something like it's overloading. Very simple. You just say, I want that kind of information, and that is a basic thing. This is something that PRTG and the MQTT server will set up by themselves. OPC UA, I mentioned earlier that we have an extension that could be investigated with a sensor like this, the OPC UA server sensor. It gives you an information about how busy the device is. So that would help you to, see that the load is getting too high, or maybe it's not even used where you think it should be used. So those kind of situations are handled by that as well. I'll jump quickly back. So here we have a custom sensor to ask how PRTG is doing. So this kind of sensor states that you see by default in the product in the top can also be presented in using a sensor. You know, you can also do this with a REST sensor. There are many ways to do this, but in this case, they have subscribed to this OPC UA server and asked for that kind of things. So you see here, there's the NS and then used and those kind of things. So, and this is the status field as description, and that is how we presented it. And that gives you that oversight. That is what helps you. In our European side, people said that they would like PRTG to be able to push that information out. Yes, for both MQTT and OPC UA, we can also make notifications available to people who want to receive that kind of messages. Right, based on the fact that the time is running out, I will quickly jump to a Kentix device. We saw that picture already from that multi-sensor device, where we here have the humidity. And again, we use SNMP custom for that. So in this case, you see that the sensor is getting a lot of stable data, and you see the temperature rise at some point in time. And luckily, it's not too high.
Conscious of time, Henk, let's move on and go straight to the poll.
Yeah, let's do that. Let's do that. So this is one of the last screens I had in mind before Stephen pointed me to the time. So you see here, we subscribe using the MQTT protocol and tell what we want to get out of a device. So definitely that is where we want to be. Right. I know I can talk lots and lots of time of sensors, and I'm happy to do that with you. So if you need me or one of my colleagues, then Jim and I will kindly set one thing up to you. Hey, there is no poll over here. That's what I thought. Oh, there he is. So, sorry.
Yes,
Too quick.
thank you, Hank. So time for a quick poll again. And this time you're going to see it on your screen. We want to know which metrics do you need to monitor. You can see the options there: time to shut down, switched up from regular power, UPS health, battery status, other, or if you're not sure, you can also choose that option. And I'm going to stop it in 2 more seconds. That's it. We can see the results here with UPS health and battery status being the #1 metrics that you're interested or that you need to monitor. Okay, so I think we're out of time, but let's very quickly go through some questions here. We have one. How can I monitor battery health? Who would like to support us with that one?
I can take that one. So with all of the UPSs, typically we'll monitor them via SNMP. And if there is any metric that you want to monitor via SNMP that is not included in one of our vendor-specific sensors, then you can do this via a custom SNMP sensor. So it's just a case of sourcing the MIB file from the respective vendor, importing that using our MIB file importer, and then creating a custom SNMP sensor to monitor that particular metric.
Thank you very much, Stephen. We have time only for one more question, which is, where can I find MIB for Eaton, UPS, and PDUs?
I can quickly take that one as well. So all of the MIB files need to be sourced from the respective vendors. So whichever vendor you have, reach out to the vendor for the MIB files, and then you can use our MIB importer to put them into PRTG.
Thank you, Stephen. And before we leave, Hank, if you can go to the next. Thank you. We want to remind you that our next Monitoring Matter session will take place on November 6th. We will show you how to monitor multiple vendors on your storage landscape to master key metrics like capacity utilization, I/O performance, rate health, or temperature monitoring. You can follow the link on the slide, but don't worry, because we're also going to be sending you an invitation soon. And now, yes, time is up. So again, thank you. It was great to have you with us today. Remember that you can always reach out to us at sales@paessler.com. Your feedback is important. So when we close this webinar, a window will pop up, and there's a quick 2-minute survey that we will really appreciate your help with. And look out for the follow-up email with a recording and other useful links. And see you next time. Bye.